Okay, for second session, we continue to learn about mole. Now we look at how many solute. We focus on the solute. We can calculate back how many solute that we do. Now we look at ionic concentration. Just for info, for chapter 4, most of the solute that we use will be ionic compound. So what we learned in chapter 1 or chapter 2, we already learned what is ionic compound from periodic table, what combined with what will form ionic compound, and then what is covalent compound, and so on. So most of the compound or chemistry that form inside chapter 4 will be ionic compound. Now, this is also important part, which is, I forget whether this one come out in your final or your test one. Later, I'll let you know. This one is sure come out in your assessment. Okay, there's one question about this one. So we want to know. Okay, now we want to learn about how to find the ion concentration. As what I write on the whiteboard here, let's say you have A plus B NaCl. Na is positive charge, Cl is negative charge. We want to find individual ionic ion, the molarity of A, how many molar of A, how many molar of B. So let's say you have 1 mole of glucose, C6H12O6 solution, indicate that the solution contains 1 mole of NaCl per liter of solution, right? So this is the molarity definition. Molarity tell us that molarity M equal to mole of solute divided by 1 liter of solution. Okay. So however, the reported concentration of the solution contain ionic compound reflect the concentration of the solute before it dissolved in the solution. Means from the molarity itself, we can find how many mole of solute, the top component of the fraction, how many mole of solute that you use, right? Okay, now for example of CaCl2, 1 mole of CaCl2, as what you learned in chapter 1 and chapter 2, you know that from here to form CaCl2, you need 1 mole of calcium, Ca, and 2 mole of, or 2 molecule of Cl. So from here, if you are saying that you have 1 mole of CaCl2, inside this solution, you have 1 mole of Ca2 positive per liter of solution and 2 mole of Cl negative per liter. Okay. Now in chapter 1, chapter 2, we already answer why Cl is 2 positive, why Cl is 1 negative. We will not repeat that, right? So those newcomers, you need to refer back to the recorded video for the charges by referring to periodic table. Okay, yeah. Okay, so this is the definition when we want to find the ionic concentration. Okay, so here, determine the molar concentration of Na plus and PO43 negative in a solution of Na3PO4 solution. Okay, it gives you 1.5 mole solution. Okay, now to start, you need to know 1 mole of Na3PO4 in 1 mole. In 1 mole of Na3PO4, 1 mole inside the ionic solution. How many mole Na you have? 3 mole. You have 4 mole of PO4. Okay, so from here you need to break into 1 mole. I mean, you need to convert back to 1 mole. Simplify it. The question asks you, How many molar concentration of NaPO4? The ionic charge in 1.5. So you need to write some statement. In normal 1 mole of Na3PO4, got how many ion positive, got how many mole of ion negative. Then only you answer the question. The answer give you 1.5 mole. So you just now you give the definition of 1 mole of Na3PO4, 1 mole got 3 mole of Na positive, PO4 4 mole of PO, sorry, not 4, it's 1 mole. PO4 is 1 molecule, 1 ion. It's 1 mole, 1 mole here. Sorry, 3 mole and 1 mole here. Yeah, 3 mole Na and 1 mole of PO4. Understand? Okay. So molality of Na will be 3 because you have 1.5 liter mole. You just take 3 because you got 3 mole here, 3 Na, 3 bracket 1.5 mole. You have 4.5 mole of positive ion Na plus. So this basically you use the unknown of the ionic compound. Nothing complex here lah. You should able to answer PO4 3 negative, right? How many? How many more? How many more PO4 3 negative? If you understand Na positive is 4.50 mole. How many mole of negative ion? How many? You understand or not? Understand why 4.5 or not? You understand or not? You understand why 3 or not? You understand why 3 or not? Yes or no? Write something on the whiteboard. CO2, you familiar, right? Carbon dioxide. You're familiar, right? This one? How many C have? 1. If you break CO2, right? How many O? O2? 2 mole of O oxygen, O atom. You got 2. Okay? But of course, ionic NaCl, positive, negative. You have 1 mole Na, 1 mole Cl negative. Here, it gives you Na3PO4. It asks you Na positive. How many Na positive? 3. That's why you multiply 3 here. It asks you PO4, 3 negative. How many PO4? 1. So, how many mole of PO4, 3 negative? 6. How come 6? How come 6? Okay, maybe I need to draw a bit so you can see. Not 6. How come 6? How come 6? How come 6? How you get 6? 1.5 times. How you get 4? Okay, I draw something on the whiteboard. Inside here, got 1.5 mole of Na3PO4. Okay. I take 1 molecule ion of Na4. I pull up. I will see 2 ion combined together. I will see Na, 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 positive, positive, positive. Because Na3, the question already give you the individual atom Na positive plus and PO43 negative. PO43 negative only have one ion, one body of ion. It give you already one unit. This one is one unit. PO43 negative, one unit. So this one is ask you the question Na positive got how many mole? Okay, inside here 1.5 mole. Repeat 3 times. So here equal 3 multiply 1.5, you get 4.5 mole of this Na positive charge. Because here 3 Na ion inside. Okay, this one don't confuse with the solution mole and don't confuse with the compound mole. This question asks you compound mole. It asks you the input. So PO4 3 negative, how many mole? Still 6. What's the answer? 1. I draw on this already, right? Inside this solution, total, you have 1.5 m of these Lego bricks. These Lego bricks consist of sub 3 Na and 1 sub Lego bricks. It consists of 4 Lego bricks. The question asks you, right? Maybe I use color. Green color, you get 3 pieces as 1 unit. And the red color is another unit. Okay? So inside 1.5 mole of these Lego bricks, blue color Lego bricks, got how many green color yellow bricks, Lego bricks? You break into Lego bricks. He asks you what is the green color, how many Lego bricks green color you have inside the container. So that's why in the solution for the green color Na positive, you multiply 3 because for 1 blue color Lego bricks, you have 3. You 3 multiply 1.5, you get 4.5 molar of the Lego bricks, of the green color Lego bricks. If you take away and then you count how many green color Lego bricks you have inside the container. Now, the question asks you another one, PO43 negative. It asks you, inside this container, got how many red color Lego bricks? It's not 1, How many you have as a total? 1.5 mole. So the answer is 1.5 lah. Okay. Yeah, you need to see as you need to break down the question. Yeah. Now we look into ion molar. Ion molar. So before this, we look at the total concentration inside the solution. Now we look into inside the total solution concentration, how many ionic Lego bricks that you have, positive and negative charge. How many you have inside the container or inside the solution? This is a simple logic for chemistry. Now you see it, can Right? Make sense? Can Right. Now, a same example. Can you answer this question? Determine the molar concentration of C2 plus and C minus in a 0.75 mole of CaCl2 solution. So for one blue color Lego bricks of CaCl2, you only have one Ca positive, and you need two Cl to form the Cl2. Right? So by looking at this, how many Ca positive you have? One. You have one unit, one set of Ca, but the solution given you already, right? Solution is how many? 0.75. So you take 1 multiply by 0.75. You get the Ca positive charge molarity, the concentration of the ionic. Now the question asks you about ionic ion, the small Lego bricks inside the container. Okay, so if you're able to understand Ca2 positive, Ca positive charge ion. Okay, just to recall, positive ion in chapter 2 or chapter 1, we call it cation. Negative charge, we call it anion. So in test, I won't ask you positive charge. Maybe the question straight away asks you, how many molar of cation inside the solution? How many molar of concentration of anion inside the solution? So you need to know the language that we use. Okay, so for Cl2, you multiply 0.75. Right. Now, in solution of 0.15 mole in K2SO4, what is the concentration of K positive in the solution? So again, to answer this question, I mean, all of you are boys. If I use Lego bricks, you're able to understand. So we just draw the container and then pull out one molecule. This molecule consists of two members. One is positive, one negative. So K, you have two. You have two Lego bricks, red color. SO4, you have one. Inside the container, 0.15 m. What concentration in K plus in the solution? You should be able to see, straight away you should be able to answer this kind of question. But of course, your exam question won't ask you this simple question. So this one, the answer will be this one, C, 3.0. Okay, the answer is C, 0.30 m. Okay, now we want to do dilution already. Just now, all the example is 1 mole, 1 mole, 1 mole, or a complete number, 1.5 mole, and so on. Now we want to dilute, means we want to reduce the concentration. Okay, now just reverse back. How we get solution? We take solute combined with solvent, we get solution. If you see the word dilute, what does it mean? Do you add solute or solvent? If you want to dilute, you add solute or solvent? Solvent, you add solvent to dilute. 1.6 asks you, okay, now it's 4.7. 4.6 and earlier is ask you all about solute. 4.7, we go into solvent. Okay. Now to save space, normally we will buy a high concentration solution, then as a stock solution. Concentration is a stock solution, means you reserve a high concentration of stock. All right, they call stock solution. This is the language where you communicate with chemists, or lab technician. You say, Cik, I nak ambil stock solution. Stock means high concentration. Okay, so for your info, they are sell, for example, acid that we buy from the market. They are in 12 mole stock solution. 12 mole. So how you know stock mole? 12 mole. This one is concentration. This is not 12 mole. This is in, you see the concentration in this slide is 32 to 36%. This data is for 100 ml. Okay. So we dilute with a solvent. Okay. Now we want to know how much we add the solvent, or how much we add the stock solution. We still play around with the two, solute and solvent, to get the solution. 4.7 solution dilution, usually you will be given the final solution molality. You need to find the solute or solvent. Okay. Now, first equation for this session will be dilution equation. M1V1 equal to M2V2. In chemistry, capital M is molarity. V, capital V is volume. Of course, this one is, if you in physics class, this one is momentum equation. M1V1 equal to M2V2. This one, if this one is right, but we are in chemistry too, so this one is in molar and volume. Okay, 1 means earlier, 2 means after. Okay. Dilution equation, if you dilute, the molar means the amount of atom or molecule must be the same no matter how you mix. Because one is in high concentration, you add another solvent, you have the same amount of atom or molecule inside the thing, the two things. That's why we can use this equation. So if the question you see dilute, this word, next step in your solution or in your answer, you need to write the dilution equation M1V1 equal to M2V2. Then you need to tell me what, okay, normally I won't check again. So unless your handwriting a bit, a bit. Some of you, M or V, you write like U, then our question. Write too fast, you just shape like U, then I will circle our question mark, what are you writing? Okay. So if you take mole, multiply molality, multiply volume, you will get mole. If you learn physics, cancellation of unit, so M, V, M is in mole per liter. Volume is in liter. Okay, liter. So you cancel the unit. At the end, you get mole. So when you see mole, means it's still concentration chapter. There are only two concentration equation in chapter 4. We are right on the whiteboard. Percentage of mass or molality. Only these two. Okay. So, okay, lab call a procedure, asks you to do something, to dilute something. So you are given 1.5 mole of KCl solution in 5 liter. How should we prepare this solution from a 12 mole stock solution? You are given stock solution. Then you need to tell, or like this kind of question, you need to write the steps. What do you do? How do you do? So first, you write the dilution equation. M1 V1 equal to M2 V2. Okay, M1 V1 M2 V2. The one on the left is earlier. The one on the right will be after. So you are given the stock of 12. So this one usually earlier you have 12 mole. Volume you don't know. You don't know, you put an capital X there. Just represent you don't know. M2 you know. M2 is 1.5 mole. Volume is 5.00 liter. Okay, this capital M, remember to change into the correct unit. Capital M also means mole per liter. Capital M also means mole per liter. That's why you can cancel the unit liter. Okay, so here also same. Capital M you can change into mole per liter. So the question asks you, the procedure actually asks you, how many liter of solvent that you need to add, or in this case is your distilled water lah. Okay, so here if you look at this equation, only one unknown, capital X, only one unknown missing. Rearrange this mathematical solution equation, you get the X. Once you get the X, you need to answer the question. It asks you procedure. How to prepare. So one, you need to take how many? If you press calculator, you get the X. Okay, so as you can see, you rearrange the equation. You write dilution equation M1 V1 equal to M2 V2. Rearrange, the V is missing. You find the V. Okay, remember when you write answer for chemistry 2, please write your unit inside your substitution. And then cancel the unit for me. You need to show the unit. Okay. So if you cancel all the unit, you'll arrive at liter. V1 is 0.625 liter. So you add 0.625 liter of solution. Okay. So in this case, you just use solvent, right? You just use solvent. Okay, you pour 0.625 liter of 12 mole of stock solution into 5 liter, into a 5 liter of the vase, the flask. Then you'll get 1.5 mole of KCl solution. Yeah. This is useful for your lab report later. You need to write this dilution calculation, like okay, how you get how many mole of something. Right? Of course, for your convenience, the lab tech will mix the solution for you. But in your lab report, you need to tell me how to get the quality. Okay. Any question? These slides? Yeah. Right. So this is just an illustration of how you make 5 liter of 1.5 mole of solution from a stock solution of 12 mole. So you calculate just now 0.625 liter. You pour 0.625 liter of 12 mole stock solution inside there, inside the empty flask. Then you dilute with water. You add the water until the marking here, the marking on the 5 liter flask. Yeah. So this is how you prepare 1.5 molarity of KCl. Okay. If you want to increase the concentration, what do you do? If you want to increase, let's say 1.5 mole to 2 mole of KCl, what do? You add this one, you add the volume of this one, then you dilute again. Okay, of course, you need to do calculation a bit lah. It's the second step already. Huh? Okay. Right. Okay. So again, if you want to increase 1.5 capital M KCl into 2 mole, you need to work back the previous example that we have gone through. You need to work back the previous equation that we've gone through, 4.6 and above, and earlier. Okay, can? Okay, this is how you work lah. Okay. So basically, the mole is the same, left and right is the same. We do the calculation. Okay, to what volume should you dilute 0.5 liter of 15 capital M molarity of NaOH solution to obtain 1 mole solution? So again, first step, you see this kind of, you see the word dilute already in the question. You see dilute already. First step, write the dilution equation. M1 V1 equal to M2 V2. Write that one. That one got 1 mark. Without that general equation, you miss 1 mark. So very easy to score for chemistry 2-1. At least you will get 50% if you write the correct equation. Okay, at least 1 mark per question. Per question. Okay, so here you write M1 V1. There's something happened. Something missing. In this case, will be to obtain one mole of NaCl. This one is M2. The given M2. This one 0.1 liter. This one is V1. 15M is M1. So you only lack of one unknown. You rearrange the equation. You're able to find your V2. Okay. This is 4.7 solution dilution. Again, try to think how your lecturer trick you or ask you a question. It might give you question from the previous section. Maybe your NaOH will be given in gram. You need to convert gram into mole. Then you do the calculation. Okay, for example, this one, this section, last section, 1.5 mole NaOH solution. I can change this one, the last sentence, this one, I can change into, let's say, 100 grams of NaOH solute, add into a certain liter of water, for example. Then I give you the water density. So from there, you need to find molarity of the solution. Yeah. So this here, of course, is very direct. But when it comes to test, it will combine what you learn into one question. Yeah. When you do revision, you do ask, how do I find, or how your lecturer modify this molality into small component? Then are you able to do? Okay. So this one again same. How much 6.0 m NaNO3 solution should you use to make 0.58 liter of 1.8 mole of NaOH solution? Here, although you do not see the dilute, it gives you 2 molarity, 2 volume. So it's M1V1 section, dilution section. Okay. You're given the M, and then ask you volume. Of course, this is not a good question. It will ask you, the proponent will ask you, how much in liter of solution, and so on, right? So here you are given the capital M molality and then volume. So actually it's a dilution question. Okay. And then this is also the same. What is the molality of a solution in which 100 ml, you see I changed the unit already, liter into ml, remember, to check what are the final answer that the question intend to ask you. This one is in ml of 1 mole, again, 1 capital M is in liter, mole per liter. So this one is ml, of course, it expect you to do some conversion already. Dilute in 1 liter, dilute in 1 liter. So same lah, M1, V1, M2, V2. You just need to be careful on the milliliter lah. Make sure the unit is the same lah. Okay. Now you know how to dilute things. Next, we go to stoichiometry. So this word also you learn in chemistry 1. Stoichio means you balance the equation. Okay. So this one you read, this one you read. You read, So just now we learned about capital M, we learned about capital V. So we use the capital M, the V, M and V to calculate number of mole of reactant or products. Reactant or products. Okay. Now in chemistry, we know we can always take A plus B equal to C plus D equation, and then if it is to the left or to the right, we will convert the reaction as a arrow. The one on the left arrow is called input, or call it reactant. The one on the right hand side of the arrow or process is called product. We will use stoichiometric coefficient to convert the other quantities in the reaction. Means you balance the equation. From the balance equation in chemistry 1, you learn the small unknown of, let's say, A plus B equal to C plus D. In front, the capital A, you have the small a with the coefficient, how many mole of A plus how many mole of B will come out with the C plus D. This section, we will study the small a, small b, small c, small d. Yeah. So we still play around the volume and mole and so on. Okay, so if you see the question with the chemistry reaction like this, usually it's fall under stoichiometric section. Okay, now consider the reaction for the neutralization of acid, sulfuric acid. H2SO4 sulfuric acid plus NaOH, you will get Na2SO4 plus H2O will form acid. Alkali, you will form water. Okay. In later chapter 5, we will particularly focus on acid and alkali or base, but this one we focus on concentration first. How much? How much means how many liters lah, volume lah. How much? 0.125 mole of NaOH solution do we need to complete neutralize 0.25 liter of 0.175 mole of H2HO4 solution? Okay. Now, if you go to this question, yeah, write something on the whiteboard. Yeah. Small a, big A plus small b, then you get C plus D. So in this question, how many more H2SO4 you have? How many more? One, huh? If you don't see anything in front, it's been one. One more H2HO4 combined with 2 more of NaOH will form 1 mole Na2SO4 will form 2 mole of water. The small ABCD, this one is how many mole, right? Or we call it coefficient of stoichiometric, stoichiometric coefficient. Okay, all these are in mole. In chemistry, we talk about mole first. Then from mole, we convert into gram or liter or volume and so on. Now you are given 0.25 NaO. So you're given this section. Actually, you are doing ratio actually. Mathematic ratio question. You put 0.25 here. Then you have 0.25 liter of 0.157 mole of H2SO4. Here you have this one. Link back what you learned just now. How to find mole M1V1. Okay. See how we do? Okay. This is just a mind map. It's just a mind map means your conversion, mathematical conversion or relationship you use. So now you have H2HO4. How many you have? You have 0.75 mole of solution. So maybe it's more easier if you draw something for the solution. H2SO4 plus 2 NaOH, you get Na2SO4 and water. Okay. So now now you have, for this component, you have 0.175 mole. Then you have 0.175 mole, but this one you're given 0.225 liter. Huh? Now he asks you how much NaOH solution, this one, to neutralize this one. He asks you NaOH neutralize H2SO4. Right? From this equation, how much 2 mole of NaOH mixed with how many mole of H2SO4? 1 mole, means You need 2 of NaOH combined with 1 mole of H2HO4. This is the ratio, golden ratio. 2 combined with 1. Now, he asks you, you are given this one. You are given 0.17 molality. You have the volume. You take molality, multiply by volume, you get mole. Capital M multiplied by capital V, you get mole, MOL. I already show you on the whiteboard just now how I cancel the unit just now. Use the golden ratio just now. You're able to find. Okay, so this is just some mind map. How you find H2HO4 mole is this one, 0.75 mole per liter. You get the capital M of H2HO4. Right? This one, the mole, capital M, this one, 0.17 capital M. You convert into MOL, small m, MOL divided by liter. You break it down into smaller unit. Okay? Break the capital M, I mean the skill set of steps. Break the capital M into mole per liter. Same you do once you're done for the capital A or the first reactant. H2HO4, you done already. Done for second one. NaOH. NaOH give you 0.125 M, capital M. Same, convert into MOL divided by liter. So from the equation, you know that golden ratio is 1 mole of H2, HSO4 or 1 mole of capital A reactant. It must match with 2 mole of capital B reactant. A plus B, A plus 2B to form the stoichiometric. This is the steps. So if you want to do reaction, you see the reaction neutralization. Basically, this is the first step you need to do in your answer. Convert capital M of A, reactant A, capital M into mole per liter. Convert the capital M of B, the reactant B, into MOL per liter. Then look back at the reaction. How many mole of A combined with how many mole of B? So like this one, 1 H2SO4 to 2 mole of NaOH. You don't need to write the bracket. In your answer, you don't need to write the bracket. The bracket just a explanation for you. Yeah, this is the first step. For chemistry 2, actually, is very mechanical, very robotic one. Step 1, you do what? Step 2, you do what? Step 3, you do what? Then you forget the answer already. Yeah? Any question? Why 1, why 2? Can absorb, why 1 mole here, 2 mole here from the equation, Right. Then you calculate in how so many liter of A reactant, you convert into how many mole in the liter. So you are given 0.225 liter of SO4. You're given this liter. Multiply by the molality, which is 0.175 mole per liter. You will get 0.225 liter of H2SO4 is equal to 0.039 mole. Convert liter into mole. Yeah, convert liter, capital V, into mole. Okay. Then from this mole, from this mole means this one 0.039 mole of reactant A must combine with how many reactant B? So here Y2 to 1. Here, if you don't understand this one, I will do on the whiteboard here. I'll do on whiteboard here. I'll write on something on whiteboard. From the stoichiometric, 1 mole of H2SO4 combined with 2 mole of NaOH. Now you, from the calculation, you have 0.039 mole of H2SO4. You don't know this one. You don't know how many mole NaOH can combine. What you do, you cross the equation. If you don't know, you just cross the equation. Cross the equation. Rearrange the equation. X multiply 1 mole equal to multiply 0.039. Rearrange this one. X 2 divided by 1. 0.039, you get the X. X will be 0.078 mole NaOH. Yeah? If you don't know, you just refer to the whiteboard. You write the ratio, then cross it. Okay? Yeah? So how to dilute equation? How to do stoichiometric equation? First, read the stoichiometric equation, understanding the golden ratio, right? So convert A mole. All right, huh? Convert the M into mole per liter. It can be, okay, let's say I write the general equation, A plus B, C plus D. A, B, C, D. Okay, convert the A into mole per liter. B mole per liter. Sorry. Okay, maybe I write something like this. A. Okay. Mean I write a big bracket like this lah. Mean big, if you see big bracket means capital M lah. Okay. Molar, molality, you convert in the question, as long as you see capital M, you convert to mole per liter. Okay. Second, you get the ratio. Ratio of A to B. The two reactant. How many A to B? Or small a to B? This one, you look at the front one here. Okay. Once you get the ratio, then you do conversion. You back to the question, you'll be given numbers of mole here. Okay, you'll be given M here, M here, M here, M here. So convert this one into mole per liter, mole per liter, mole per liter, mole per liter, if you have lah. Okay, then from here you'll be given, okay, you'll be given volume. Multiply this volume to this one, you'll get mole. Mole. Okay, so here, when you get the mole, just use back conversion back to what the question want you to calculate. Okay, important is you get the ratio correct. Then you just convert capital M into mole per liter. Okay, so here the question asks you how much of 0.125 mole NaOH you need to complete neutralize this one. So basically, you convert whatever the question give you into mole unit. To mole unit. Okay, this capital M change into mole per liter. This one liter and this one capital M into mole per liter. If you take 0.25 liter multiplied by 0.175 mole per liter, you get mole. These two combination, you get mole. So once you get the mole, you get the golden ratio. Get the golden ratio, then you cross it. Like what I did on the whiteboard there. You cross it, you write in this equation. So like, if you cross it, you'll get 0.039 mole H2SO4 multiplied 2 divided by 1 equal to 0.071 mole of NaOH. Yeah, so these steps here is to get how many mole NaOH you need to dilute H2SO4, to dilute 0.039 mole of H2SO4. Yeah, so if you take 0.39 and 0.078, actually is 1 to 2. The ratio is 1 to 2. Yeah. Then from there, you need to answer the question. The question asks you how much. How much means volume. Right? In this case, solution. Solution unit is volume, liter. So if the question asks you without the solution, it means ask you gram. If the question change, I remove the solution in this question. Ask you how much 0.125 mole NaOH means it asks you solute already. But if you see this one, usually I'll ask you the liquid one in volume. Okay, the final answer is 0.63 liter NaOH solution, like what you see on the screen here. Okay. Okay, once you get the liter NaOH. Okay. Once you get the liter, okay. So your final answer, you need to give me a conclusion. If you see a long question, something like this, you need to give me the conclusion. Conclusion, you write, it will take 0.630 liter of NaOH solution to complete neutralize. You need to write this statement for your test 1 and test 2 and final exam. If you finish at 0.620 liter this calculation, your marks only stop at calculation steps. Okay, there will be marks for your conclusion. You calculate something, you get a number, you need to tell me for section C marks, you need to tell me what does that number mean. In this case, you need to take 0.630 liter to neutralize. Liter of what? NaOH to neutralize the H2SO4. Yeah? This one, okay. So just a quick mind map. We don't need to do the calculation. Let's see if we're able to think step first, understand the step, because I can change the value in the question. If you're given this equation, 2Ki plus PbNO32, you get Pi2 and 2NKNO3. How much Ki solution in liters will be completely precipitate Pb2 plus in this solution? This question combined with the ionic concentration just now. Okay, this question combined with the ionic concentration that I draw the small Lego bricks just now. Huh? Okay, so I try to show you the steps without the numbers. At least you see the logic behind. Important that you understand the logic behind. Why and why we do so and how we solve it is more important. Okay. All right, in very general equation, a small a plus small b, b, you get c, c plus d, d. All these are in liquid. Now the question give you a question given K, okay, KNI3, you are given the molarity of A, which is the capital M. A is given. So if capital M, you know, and you know that this is, you see the equation, you know the step is convert capital M into mole per liter. This one don't need to ask already. You see the equation, you are given the mole, the capital M there, change the capital M into mol per liter. So first step, 0.115 M change into 0.115 mole per liter. This one refer to Ki solution. Then complete precipitate Pb2 plus in that one. So that one later. We are more interested. The question asks you Pb2 plus ion. This one later. Okay. In some liter of 0.225 M. 0.225 M. This is the B. 0.225 capital M change to mole per liter. 0.225 mole per liter. This one is PbNO3. 2. Then, you know that question asks you ion. Look this one, if you see ion, look this one as a Lego bricks. Okay, this Lego bricks PbNO32. This is one Lego bricks. I'll use blue color to represent Lego bricks. These Lego bricks you can break into two small Lego, which is the red color and the orange color. The red color and the orange color. They are drawn on the whiteboard here. Okay. So just now, what we do is that the previous solution one is, remember the container. As long as the container have a certain M, you will multiply by how many in front of the small Lego bricks. So this one is 1, 1. So later you need to find how many M of this one, of this one. Yeah. Okay. And this one is in liter. Okay. So you have liter. And from the equation, 2 Ki to 1 Pb NO3, 2 mole to 1 mole PbNO3 2. You have the ratio already. Okay. So step 1, convert capital M into mole per liter, then get the ratio. Once the ratio, you're able to find already. So you are given 0.104 liter and your capital M. This one, capital L, multiply by capital M, you get volume. Sorry, you get mole. This one you get 1 mole already. So once you get mole, you get this mole. So you write the ratio lah. So you have this mole by taking 0.104 multiplied by 0.225 m. This is mole already. This is mole. So this one I will just write as, let's say this is your x lah. You already find your x. So this one you don't know. Your y you don't know. Cross it, you find your y. Okay? Once you find your y equal to 2 multiply x divided by 1. Because you cross it. Okay, you get your y equal to how many mole of your Ki? Right? Get how many more of your Ki? So this one is 1. Your PV is 1. So PB2 positive. So you know that this one, you have this PB is 1. So your PB got how many mole inside? PB2 plus here is 0.025 mole. This positive charge, you have 0.225 mole of PB. So you rearrange the equation. Okay, I'll show you the steps. Okay, first you find the M into mole per liter. Capital M mole per liter for Ki. Capital M NO32 into mole per liter. Find the golden ratio. In this case, 2 to 1. 2 to 1. Next steps. You are given a liter of PbNO2. This one. Liter. You multiply by the mole, capital M. You get how many mole. Convert this one into mole. Take the capital L, liter, multiply by capital M. You will get mole. So convert this one in mole. The objective, the final objective of all the chemistry question, you need to get to mole, MOL, small MOL. Then from there, you can continue. It's the currency that you need in chemistry too. Convert, always convert until you get mole. How many mole of something? Then you do the cross. You know that 2 mole of Ki will mix with 1 mole of Pb. So you take 0.032 mole multiplied by 2.1. Why 2.1? I already show on the whiteboard here already. Okay, you have 2, 1. You already find your x here. Y is missing. Cross it. Write the equation. 2 multiply x equal to y multiply 1. Take the 1 from the left to right. You will get 2 divided by 1. You need to show me these steps in your calculation if this one come out in exam. You don't suddenly press, then give me one magic number. No, you won't get marks. Although the number you guess is correct, you won't get marks in chemistry too. Without showing me the steps, you press anyhow, you very pandai to press calculator. Let's say this question come out, you give me 0.0468 mole per Ki. I'll put a question mark, how? You won't get mark for this. You need to show me how you arrive at that number. Okay. Then once you get the mole, the question asks you how much, means volume already. If how much? Convert mole into volume because it's 0.015. Capital M is mole per liter. Convert the mole into liter. Here, convert. Okay. Convert into mole per liter. Just a conversion from the ratio. The final answer is 0.47 liter Ki solution. Well, 0.47 liter Ki solution of 0.118 capital M Ki solution will completely precipitate Pb2 plus in the solution. You need to write the statement. You need to write the statement, final statement of what is this? What does it mean? Okay. This is your homework. This is your homework. Okay. This one. This one maybe I reserve for after your test two, test one. This one actually, I want to do ice cream exercise in the class. We will make ice cream maybe week 8 or something. Right? So you will shake like if you went to some of the science camp or something, we'll make ice cream in next lecture, right? I think this one you read lah. This one you read. We'll do this one in our next lecture. So next lecture, you'll see me bring milk, ice cube, and all these things. Right, so your lunch will have ice cream to enjoy lah. But that one will be in week 8. Okay, next week is your test already. So week 8 we'll continue to do this one. Right? Okay, week 8 only we brief you lah how to do. Okay. This one you read first. This slide I give you. Next class, next class after your test one, we will learn another new thing with a small m. Just now, the capital M is molality. This is molality, a small one. This will be in next class. This one, I give you the slides. We'll go through this one again in week 8. You just go through, nothing complex. You just read through. Okay, we continue 4.9 in week number 8. Let me see if I finish. Okay. Let me end the recording first. And then I will share some info with you.